Also book an examination for that assignment. And this is only for higher grades. And you select a date and a time that suits you within those available dates. So, okay, so the actual examination is going to be as follows. You're going to contact us on Slack 20 minutes before your time. Then you're going to get a link back to I guess a Google form with a couple of questions that we want you to fill in before the examination. And during that time, we're going to examine another student at the same time. So if you don't get an answer directly, you're probably going to get it in a few minutes. But the idea is that you're going to be able to answer a couple of questions for us before even starting. And then during the session, we're going to call you on Skype. So you need a headset. And you need to set up sound in Skype so that it works, so that you're ready to be called. And we use Slack as a fallback channel should something fail for some reason, right? I prefer that you also have a webcam so that we can see each other and I can put a face on the student, so to speak. I also want you to open your programming environment and have every part of the code that you've produced ready. And that you also can run your tests and run your program. And we're going to ask you a couple of questions. In the assignment description, you can see different categories that we're going to sort of try to put a value on you on these different categories. And I got a question on Slack today on how complex, how large must the project be? And the answer to that is it sort of depends, but for the highest grades, we want you to have put a lot of effort in working with TDD and working with JUnit and have lots of tests and lots of commits, right? Because that effort is going to show for something. But it could be that you're changing, somewhere in the process you've switched from one project to another project or something like that. So of course both projects counts, right? Yeah. So I know that a lot of students get nervous, but I mean it's me and Josef, and we're really kind, and we're just trying to find out as much as possible, but probably within a little time frame, right? So please just answer the questions that we ask you, and we might interrupt you in order to be able to answer all these questions that we want you to answer. There are some study questions. We've probably seen those. It's a good idea to, before this examination, to discuss these study questions with some friends or in the Slack in order to try to understand those, because we can ask you these questions or similar questions to those. Yes. Clear? It's usually a quite busy week for me when we're doing this. So yeah, if there is a small delay or so, might be that we're not quite finished with the student before you. Might take a couple of minutes before we can address you instead, right? Okay. So now let's get back to test case generation. And this is a recap of test cases. So this is from, I think, the first lecture, right? So what is a test case? In order to have a test case, we need something to test, and that we call that the system under test. The system under test in the example here is the function power function, right? Then we have some input, and these are the things that are inputs for this function or this program. When we're talking about a unit test, it's probably that we're just testing a function or a method of a class, right? But if we're talking about a program, this input may be very much larger and very much more complex, right? Input in a desktop application or in a web application is movement of mouse, it's pressing buttons, it's inputting text into fields, all that actions that can be inputted, right? But it's also information that comes from other APIs, perhaps, that your program is using, or from databases and stuff like that. So all that is input, stuff that gets, or information that is sent into our application. And then, in order to have a test case, we also need an expected output. So that is number 3. So the expected output of putting a 3 into a power function is 9. Yeah, and we, as testers, are often the oracles that decide this, right? Then we have some actual output. The actual output may differ from the expected output, and we need to have a decision made if this is if these are two are the same or not. And that was also the oracle's the assignment of the oracle, right? Perhaps we also have an observed behavior, and that was the value that we as tester, or the system that tests the system under test, is actually seeing. So if the actual output was 9.000001, we might only show 2 decimals, right? So the observed behavior might be something else than the actual behavior of the program. This makes it a bit hard to know if the expected output and the actual output are the same. Okay, so this image you've also seen from the last lecture. So we have talked a little bit about how to generate test cases from requirements before. And this is the requirements pyramid from IBM. It says that the customer or the stakeholders has some needs. These needs are to be fulfilled by our system, our program, right? We try to capture these needs into features. Perhaps we can log into this system. Perhaps we have a feature that is the POW method or something like that. These features are then, once again, captured into use cases, these user stories that we write in order to be able to discuss these requirements with the customer. We write these small stories. I'm going to show you the example from the last lecture soon. And each of these use cases can result in different scenarios. There's sort of if statements and loops in these use cases. If the user provides faulty input, perhaps we need to show him an error message and let the user input that stuff again. It may be that if we're buying a product, maybe in some web shop, maybe we should show an ad for a similar product, but at a little higher price or something like that. That could also be a part of the use case, right? In order to get the one who is buying, the customer, to buy something that is more expensive. So we have different scenarios, and these scenarios results in test cases. So from a single scenario, we can have several test cases. So the test cases differs from the scenario in that we have test data. We have number 3, and we have expected output, number 9. So those are provided in a test case, but is not provided in a scenario, right? So, yeah. So here we have a use case. It's use case 1, authenticate user. And we have a main scenario that is, I usually call this the main success scenario. And it says that it starts when the user wants to authenticate. That is, the user wants to log in. The system asks for a username, password, and if the system should save the user's credential for future login attempts or authentication attempts. The third step is that the user provides username and password, and the fourth step is that the system authenticates the user and presents that authentication succeeded. After the use case has ended, the user is now logged into the system, right? The user is now authenticated. So one path through this use case is the path 1, 2, 3, and 4. That is the main success scenario. Everything happens as it should. The user provides the correct authentication credentials and gets logged in. Everything is happy, right? But there are other paths, other scenarios. Perhaps from use case, perhaps the user wants to have the system to save his or her credentials for the next time we're going to log in, so it does not need to provide those again. So that is the 3A step, right? That is an alternate scenario. The user wants the system to keep the user credentials, and that results in that the system authenticates the user like before, but also presents that authentication succeeds and that the credential was saved. So it adds a little bit, right? But even if you provide that you want the system to save your credentials, you can fail to log in. So you can still end up in 4A, that the user could not be authenticated for different reasons. And the system presents an error message, and then we go back to step 2 in the main scenario. So we could have 1, 2, 3A, 4A, 2, and then something else happens, right? Perhaps 3 and 4, or something like that, or 3A and 4. So different paths through the different through the use case provides different scenarios. Each scenario is then provided with at least one set of input and output in order to create test cases. So we're going to take a look at another course use cases, and some of you have seen this before. So this is sort of similar, and we have a use case, and it has a main success scenario. Oh, it's very similar to the one we looked at. It's a bit differently named, but I just want you to see that it's called use case 1. And there are other use cases, logging out perhaps, right? And then we have test cases provided for these use cases. And you can see that the first test case is called navigate to page. It's named 1.1. This first one says that it's connected to the first use case. The second one is a numeric that tells us which test case is this. We can see that the test case provides different information. Since I wrote this, I wanted the tester to know a little bit on how to evaluate this. So I've given different information. And the first part is just to get an idea on what we're testing. And then we have input. And then we have output. This is the expected output. And in order to make this a bit easier for the tester, I've also provided an image on how this can look, right? This is an example of output that we can get from this. So I guess many of you recognize these if you have taken courses with me before, right? We can see that there are more test cases connected to the first use case. This one is the second one. And this one is called failed login without entering any fields. So in order to understand this one, I think that we need to open the actual system under test. And it looks like this. So it's a web application where you can log in and you can register users. So test case, and this is what it looks like if you run the first test case. So it should show not logged in, and it should show the time and the date of today. So let's take a look at the test case. We should clear existing cookies and navigate to sites. So okay, let's do that. That is our input. So let's inspect that one. Let's go to application, right? And cookies for this one. And here is a lot of information, so I can clear this here. So now I've cleared the cookies. Let's take a look at that. That was the first step of input, right? And then I navigate to the site, so I reload the page without any cookies. And now I've provided all the steps in the input. The task for me now is to manually check if the output is correct. So let's take a look at the expected output. The text not logged in is shown. Yeah, I can see that. A form for login is shown. Yeah, it seems to be. Today's date and time is shown in the correct format. Then I need to know the correct format, and it's specified up here. So it should be day of week, day of month, numeric. Okay, day of month, numeric. Okay, that is the date, right? And then month as text, year as 4-digit, time, minutes, seconds. Okay, and then we have an example. So let's take a look at the output. Okay, we have Wednesday, 30th of November. Yeah, that is in text. This also looks like okay. And hours, minutes, and seconds. Yeah, hours, minutes, and seconds. Okay, looked quite okay. I think that if we take a look at Sundays, it will fail, right? Because there is a bug in this system. As far as I know it, I have not fixed it because I found it a bit fun to keep that bug. Okay, so let's take a look at the next test case. It has passed the first test case. We decide that as tester. Failed login without entering any fields. Okay, this is the sort of idea behind the test case, to make sure that login cannot happen without entering any fields. In order to do this, we need to run another test case before this one. So we should run test case 1.1. That was clearing the cookies and navigate to page, right? So the input from that step. Make sure both username and passwords should be empty. Fields are empty, and press login button. Since I've already done that, I've not really changed anything. I can just press the login button. Both of these are empty. You can see there's something weird here from one pass, right? But I press that one. Okay, now I get some output. Let's take a look at the expected output. The text not login is shown. Not logged in. Okay, good. Feedback, username is missing is shown. Username is missing. Good. But there is a colon here. No? No, it wasn't. A form for login is shown. Good. Everything peachy. Test case 1.1 and 1.2 succeeds. Yay! Good work, programmers. Cookie for you and a GitHub sticker. Then we have another test case, and failed login with only username. And you can see that, okay, we should enter a username, but let the password be empty. And let's do that. And then we press login. Okay, the admin was saved in this one. The username was saved, and the password is missing is shown. Not logged in. Not logged in. Password is missing. Yeah, we saw that. A form for login is shown, and admin is filled in as username. We can take a look at this image. It sort of looks the same, right? So good. And you can see that I provided more test cases for this single scenario, right? So all these test cases are for the scenario where we cannot log in, even if we provide information, right? So we have failed login with only password. You can see that we have actual input. What we're supposed to write in these fields are provided here. And how to do this. The presses of the buttons are also input, right? We have the expected output. You can see the failed login with only password. If we only insert the password, and let the username be empty. Next one is failed login with wrong password but existing username. So let's have a password with that is wrong. Note the little p. Okay, it's not password with big P. It's password with little p, and let the username be admin. So the correct information is password with big P, right? But I have faulty input with small caps password. And the username be admin. Then we have a failed login with existing password but wrong username. So we have password with big P, the correct one for a user, right? But we misspelled the username with a small a, small caps A. And we can see that so we're still at the same scenario, but we have different test cases for one scenario. And finally, we get to another scenario. And this is a scenario where the main success scenario, where we are successfully logging into the system with a correct username and password. And I placed these test cases in a certain order in order to find out all the cases where we can fail to log in. So even if these wrong name or password is shown for everyone, it's the sort of same output. This one is username is missing, so that could be sort of another scenario, but it's the same path in the use case. Yeah. So we can see in the bottom of the pyramid that different scenarios result in many test cases for some reason, for some inputs, right? In order to reach all different stages. So, yeah. We can provide these graphs of the use case in order to find the scenarios. Perhaps we want to have a test case where we go in a couple of loops inside inside this use case. Perhaps we take the path of 1, 2, 3, 4, A, 2, 3, 4. That is not right now not provided as a single test case in my suite of tests for this. So that you fail to log in first and then you succeed to log in. That is never tested within my test suite. It might be tested just because the tester decides to do the test cases in that order, right? Yeah. So this is one way of finding out which test should I write. But we're still in last lecture. Okay, as you've seen, there is a loop in the use case, so we can have an infinite amount of scenarios. This will result in a large number of tests. If we try to run every possible scenario with every possible input, this is called exhaustive testing. Tests all inputs in the input domain. And we've talked about it before. It is often not practically possible to do that. It will take too much time. And I think this was the example we talked about. We had a method called getMax, and we inputted an array of numbers into that one. And we realized there was so many of these, right? So it was not practically possible to do this. But even if we decide on a couple of these test cases, take a look at the inputs or the test case input of these two that I have provided. The array 1, 2, 3, where 3 is the expected output, right? And then we have another test case called 2, 3, and 4, where 4 is the expected output, right? Do we need both of these? Yes, someone says. And someone agrees with someone. Anyone? No? One, at least in campus, no. Is there anyone looking at this online right now? Would be really good point in time to tell me what you think. So we have yes and no as answers from campus. Right now we have 0 online students. Please write in Slack. Awesome. Let's see. Perhaps Salam says no. Thank you for providing some input from the online students. Okay, so why? If we have answered yes, why? If we have answered no, why? Why do we want both cases? Why do we only want one of these? Thank you. Awesome. Now I get some feedback. What do you think? What is the motivation for having two of these? Anyone?
It's more safe to have two.
It's more safe to have two? Yeah. So I can come up with at least one reason. And that is... Sorry?
That getMax method could just return 3.
Yeah, if we don't have two of these, the simplest implementation of getMax would be to return 3. Yeah. But since both of these cases are sort of testing the similar things, so if we have another test case that with an empty array, that problem that you told us about, that implementation of getMax which returns 3 is sort of solved in that problem, right? Yeah. Do we need a third case? If we take 3, 4, and 5, and do you think that is a good idea? Unsorted, yeah. But now I'm trying to find where it's sort of the same kind of test case. Yeah. So CN222HN says that they are essentially the same. Yeah. So in order to find out the answer to this, we need to go back to the first lecture again and talk about the goal of testing. The goal of testing is to uncover errors, and that was what you told us about in the corner, right? If we have an implementation that only returns 3, the other test case is good because we will uncover that error, right? The second part is to build confidence in the software. If we run 1,000 tests, we're more and every of those tests succeeds, we're more confident that the system works than if we run one test, right? So the amount and the effort put into testing it has some kind of relationship to this confidence. So, what is the ideal test suite? Let's say that we're the customer, and there is a sprint or an iteration that has ended, and we receive a version of the program that we have ordered from you, from the programmers. In order for us to accept this one, we run the acceptance test, right? So on each sprint, we get a series of tests, acceptance tests that we run on this one in order to accept that, to sign off this iteration, to say that, okay, you as programmers have done a good job, I've got what I asked for. So that is the sign-off process. Yesterday I heard a story where the customer does a very poor job at this. So if the customer does not do this properly, they might sign off that the program has done what they should, but they really don't know because they've not tested it enough. So acceptance testing might be a really good idea to have a couple of tests, and we actually run these tests, and we get an idea that we get what we want, right? So if the acceptance test is just one, took a look at the web page, it looked okay, we might forget, or we might sign off. We might say that the program has done what they should do, and in later iterations, perhaps when we have a more complex system, we find out that they didn't do what they should do during that sprint. Okay, painful regression. Let's say the programs have changed the system. the login system. So now we need to rerun these test cases. Let's do that. 1, 2, and 3, and 4, and stuff like that. So you remember the test cases by now. We should clear the cookies, right? We should navigate to the page. We should take a look at the different inputs. It should tell the day, the date, the month as text, the time as hours, minutes, and seconds. Both fields should be empty. Sort of not logged in should also be placed there, right? Then we do the second one. I don't remember the second one, so I need to read that one. I actually do remember it. So I've done it 1,000 times. Navigate to page. Okay, fade login without entering any fields. Okay, 3 different types of input. The first one we've already done. Make sure both username and password is empty. Press the login button. Oh, yeah, that was it. Okay, what was the expected output? Not logged in is shown. Username is missing. A form for login. Not logged in is shown. Username is missing. A form for login is shown. Okay, the third one was to provide a username. We should still not be logged in. Password should be missing in this, right? And then we had some other test case password with small caps and stuff like that. Okay, so let's, as you've seen, probably just with this simple example, you're already tired of this. And the students who have done this assignment is probably really, really tired now. And they never want to see these test cases again. So let's not take a look at those anymore. So regression testing, that is when we retest something that we've tested before. If this is manual, it might be painful. If it's painful, it's easy to make mistakes. It's easy to forget stuff, parts of the input, to sort of cheat. I did that a little bit, right? I didn't look at the text again carefully. And we as humans are pretty bad at doing repetitive stuff. Thanks for the laughter. I sort of need that today. Repeatable tasks or repeated tasks, we're pretty bad at that because we want to optimize things. We want to only do things once, and that is really good aspect as programmers, but for testers we need to be really thorough and we need to be really sharp-eyed, and so for these cases I would recommend that automating these tests. Perhaps do these once every third sprint and then have an automated process of doing this. You could, for instance, write a system that is testing this system. So regression testing can be very painful. So in order to have an ideal test suite, we want the test suite to be small, right? In order to not bore the tester. During development, we want a test suite that is easy to run, so it does not take too much time from our programming time, but it should still detect the problems in the code, right? And during development, we want to have confidence so that we dare release this to the customer, and we want to detect if the code I just wrote was wrong. Requirements change. When the customer sees what you've provided to the customer probably realizes, I did not ask for this. I did not want this. My goal was something else. So a lot of the programming process or the process of interacting with the customer is trying to find out what they really need, what they really want. And what we want changes when perhaps the other companies release other products, then we need to follow those. We need to have a like button on every product because every other company needs that, so requirements change. And when requirements change, we need to change the tests because the use cases have changed, the scenarios have changed, we need to change the tests, right? Or we need to add new tests. So since the tests change, we want them to be small and few, because otherwise there will be a lot of work changing each test. Hopefully, you who have worked with assignment 1 part 2 have now realized that, oh, I need to change all these tests. So, we want a minimal test suite that still gives us enough confidence. Minimal, because we want it to be easy to write, easy to change, easy to run, but we still want the confidence. So, the test selection problem, this is from Mathur, the book. Select a subset of tests that we still reveal all the errors in our program. If we have a subset of the tests, we only need to run those that sort of should fail, right? That detects problems. And if we have a problem, we would like only one test that discovers that problem, right? We need one test that discovers that problem. If we have 100 test cases and they all discover the same problem, that is not a good idea, right? I've done too much work running these tests and writing these tests, but they still detect just the same problem. So it should be like 1-to-1 factor, right? Okay. But in order to reach this minimal test suite that still gives us confidence and finds the bugs, we need to make assumptions. We need to minimize work. So let's say that one assumption could be that these two cases are the same. That 1, 2, 3 and 2, 3, 4 test the same thing, detects the same problems. So that could be one assumption. And we make that assumption to minimize our work. Another example of assumption is that if we have changed a module, let's only regression test that module. Right? It is an assumption. It's an informed assumption, because let's not test stuff that we've already tested that we have not changed. But it could be still that something has changed, but we don't know about it, right? So it's still an assumption. And do you know the saying, or at least I know the saying, that assumption is the mother of all fuck-ups. Sorry for cursing. But this is really what is the problem, that when we assume something, it's often that we forget about other stuff. Right. Okay, so let's do the get max method a bit easier. So this one returns the largest of 3 inputs, and all inputs must be positive numbers, and it should throw exceptions on negative numbers. Okay, so we only have 3 inputs instead of an array of input. That reduces our input space a lot. In this case, could we do exhaustive testing? Do you think that it's possible, practically possible to do exhaustive testing? No. No? Why? Too many in the combination of numbers, right? Okay, what kind of test cases would you select? There's sort of different requirements here, right? The first one, that we should return the largest of the 3 inputs. So I would say that, okay, if the first one is the largest, we should probably have a test case where the first one is the largest, right? And let's have a test case where the middle one is the largest. And let's have a test case where the last one is largest. It says that all inputs must be positive numbers, larger than 0. So let's have a test case larger than or equal to 0. Let's have a test case where the first one is negative something. And let's have another test case where the second one is negative something. And let's have a third test case where the third one is negative something. let's make sure that for each and every of those test cases, they throw an exception. This method throws an exception. Okay. Do you agree? Would you like to have some other test cases? Yeah, Richard? If the numbers are equal, what should happen then? Yeah, good idea. So, in this case, you've seen this image before, right? We are not addressing the code. We're addressing the requirements behind the code, or the specification behind the code. And that was called black box testing. We're only examining the functionality from the outside. We're looking at the requirements. We don't know anything about the code inside. So for the input 9, we output 3, for instance, if we think, and we think of the code as, or the program as a black box. And this is sort of the same when we're generating test cases from the use case. We have no idea on the code, and we just assume that this is a good test case because it's a path through the code. So using that kind of information, we can do something that is called equivalence partitioning, where we divide the input into equivalent disjoint subsets. Sorry for cursing again. Okay, what does that mean? Oh, it means that we divide the input space into subsets. That means that some numbers are in one part of the set, and some other numbers are in another set, right? So, and these are equivalent. And equivalent means that for each and every number in that set, in that subset, the program sort of works in the same way. They are equivalent. It does not matter which one of these values I select as input, because the program should work the same for all these values. And these are disjoint. Disjoint is a mathematical expression for not having a single input in these that are in both subsets. So they're completely disjoint, means that no input is in both subsets. So if you divide the input space into two parts, there is no input that is in both parts. So let's take an example. We have an example where we add users, and we provide some kind of age factor. And these are humans that we're talking about. So we should divide, or our equivalence partitioning is to divide into valid and invalid input. So let's talk about what is invalid ages. Negative ages, right? That is invalid age. You cannot be minus 3 years old, right? Then the upper edge is sort of a definition. I mean, there are stories of people who gets really old. I mean, 900 years and stuff. But I've selected 120 as some kind of upper limit. I think 144 is another number. But I mean, someone needs to decide what is a proper age for a human being that is alive, right? So maybe you have some other idea. I just took 120. I thought that was a good number. I've never met anyone who's older than 120. No. So that was taken. You can decide on whatever age you want. So the valid ages are between 0 and 120. And the invalid ages are between minus minimal integer value up to minus 1, right? And then all the numbers above 120. So those are the two partitions that have invalid and valid input. And equivalence partitioning should work in this way. Since we say that each value in these partitions are equivalent, I can just select one test case from each one. So let's take a number in the middle, like 5. that is a valid age. So I create a test case with a valid age. And then I take -5, and that is a good value for an invalid input. So you take one of each. Simple? Yes. I think so. Yeah. Let's take 15 minutes. Okay, welcome back to software testing, and we were talking about equivalence partitioning. So we've divided the input domain into different subsets, and these were equivalent. That meant that each input in these sets are accounted as equivalent. They should result in the same kind of output, so to speak. And they were disjoint, so that one input cannot be in two different subsets. We took the example of add user, where we provide an age, and the age was we divided that age into valid ages. That was between 0 and 120. And now oldest living human being was 117. Was that correct? Yeah. So perhaps 120 is not that bad. If someone says that they are 138, perhaps we should say that, okay, we do not recognize you as human anymore. So you end up in the unexpected invalid input subset instead. So let's just step back a bit, because I think that it's really easy to get lost and generate a lot of test cases that are not relevant anymore. And as programmers, we are often instead working with this. That is the code, right? So this was also from the first slide, and you don't really need to understand read the code, but you can see that there are a lot of if statements. And so to speak, instead of thinking of different input that is correct or not, perhaps we should sort of reach every part of this code instead, so that each part of this code is some different behavior of this code. So perhaps we should, instead of just thinking about the program as a black box, perhaps we should, at least when we're unit testing our code, think of white box testing instead. So you can see the lot of if statements. Perhaps we should have a test case that sort of reaches every part of this. And perhaps we should have a test case that does not reach every part of this also. But we're going to talk about more about that during the next lecture. So let's go back to equivalence partitioning. Here we have a piece of code. So we have the input is actually in a member variable called buffer, and that is a string, I think. So the buffer, the input to this needs to be provided through this buffer, so through some other means, some other method, perhaps the constructor or something like that. And you can see that there is an if statement. So what would be proper partitionings for this case? Perhaps by having knowledge of the code, we can see that there is one if statement at least, right? So having a test case that enters the if statement, and one having a test case that do not enter the if statement is probably a good idea, right? So we can use this equivalent partitioning also for the white box testing thingy. Then we can discuss if we need more test cases or not. But so let's make stuff a bit more complicated. Let's have multiple partition. We're still using equivalence partitioning technique, but let's have multiple partitioning. So we have another method. It's called get loan. It is who should get money from the bank without doing anything, or who should owe the bank a lot of money in the future. So the bank probably has some rules according who should get loans or not. And one of those rules perhaps is that you need to be in the age where you earn money. And also, or you need to be an adult to borrow these. But if we don't want perhaps too old people to borrow money because they might die, and never return the money. And I know some old people who are actually taking loans, but they say, I will never pay this back. So it's relevant, right? Like all my examples. The customer says that, or the bank has the rules that you must be between 18 years old and 65 in order to get a loan. After the age of 65, you're on the scrap heap. If you're a kid, you're not allowed to take loans. But we have an additional requirement that you should also earn a lot of money per year, at least 250,000 Swedish crowns, in order to get a loan. So we have two different inputs, the age and the salary. And let's identify the input domain for these. So the age, what was that? 0 to 120. We sort of decided that before at least. 0 to 118, perhaps we'll revise it too. But the salary is, you're probably not, you can of course go have a negative salary. You owe someone more money each month. I guess that is possible. But let's say that salary needs to be over 0. And there is probably no upper limit to the salary. Without being political in this world, people who own a lot of money seems to earn a lot of money also and get richer. Okay, so no really upper boundary on salary. Let's equivalence partitioning it into subsets. We already have two different subsets for the age, right? The valid age and the invalid age. We could have an invalid salary, like negative salary, but it sort of does not mean anything if we have these requirements that your salary should be over 250,000 per year. So the 249,999 is our, and lower than that. All numbers lower than that are invalid, so to speak, for getting a loan at least, right? Then we have the upper, and every value above 250,000 Swedish crowns is the second one. And we combine these. So the age is the y-axis. So we have the equivalence classes of lower than 18 and over 65. And I've changed the salary per year from per month to per year, right? Because it's only 225K. So it should be 250K. We have lower than 250K and higher than 250K on the x-axis. So if you're in zone E1, you're underage and you don't have a salary. So you don't get a loan, right? Probably a good idea to have a test case there. If you're in zone E, you're under the age of 18 and you still have a salary that is higher than 250,000 per year. I have no idea why you should need a loan if you're a kid who earns that much money, but you're not allowed. So if you're in zone E2, you don't earn enough money. You're of the proper age, but you don't earn enough money. So probably a good idea to have one of those. And in E3, you're too old and you're too poor and too old. And E4 is that you're too old, but you earn a lot of money still. Or a lot, it's not a lot of money. Perhaps for some it is. But in zone E5, that is the golden zone where you get a loan, right? So perhaps it would be a good idea to have a test case from each of every of these in order to cover it. And that was sort of what I was doing when I created the test cases for the login system. I need to have a proper username and a proper password combination. So I created test cases for all the other combinations. Then we have something called boundary value analysis. You probably heard this before. This is based on that programmers are often making mistakes selecting comparison operators. What is the comparison operator? That is the less than or equal than, or larger and equal, or not equal, and stuff like that. Those are the comparison operators. So it's quite common to make a mistake that if you're 18, you don't, and you still have a high salary, you don't get a loan because the programmer said that you need to be above 18. Higher than 18, instead of higher or equal than 18. So the program has made a mistake. So in order to find that mistake and to uncover that error, we identify the boundaries between these partitions, and we create test cases on both sides of that boundary. So back to this one. Perhaps we have a test case where you're 17 in E and 18 in E5, right? So you have both sides of the boundary, and perhaps we have a test case in E2 that is 249,999. That is exactly lower than the boundary, right? For enough money, and we select the E5 value to be 250,000 exactly, because you should get a loan, right? So the boundary value analysis checks for these boundaries and then create test cases on these boundaries. Yeah. That was sort of it on how to create these test cases. I hope you now have sort of enough information in order to do assignment 2, because you're going to create test cases in assignment 2. And I'm going to look for manual test cases. So let's talk about these two assignments. Assignment 2, and I really would like you to read these assignments quite thoroughly and think of all the things that you don't understand in these. So I would like that you do that, and then you ask questions on Slack so that we can improve the assignments, because these are new assignments. I've written them this year. I can be quite ambiguous in my expressions. I've learned that. So please find the misunderstandings as early as possible and not on the 22nd of December, because I will be home with my family and you should also be there, right? No, not at my home perhaps, but you're welcome. We're an open family, I mean. Okay, so the idea with assignment 2 is that you should write a testing strategy for an application given a scenario, requirements, and source code. So I give you the scenario, the requirements, and the source code. You're not really supposed to write any source code here. You're not supposed to change any source code unless you need to in order to test it, because there is at least one such case where you need to do that. So you should do a proper testing effort. And then you should, when you have a strategy, you should write a test plan. And when you've written that test plan, you should execute that test plan. And in that test plan, you're probably going to write manual test cases. So let's do that. You write the manual test cases, and using those test cases and perhaps some other kinds of testing, you test the application. And you perhaps run the JUnit tests and get a test result. So you will get some test results. That was which test cases fail and succeed and why, perhaps. And you report these results also. That is the gist of the assignment, right? So it's a complete test effort for some scenario with some application. It starts like a group assignment. You can be a group of 1, 2, 3, or 4 students. I recommend you to do this assignment in groups, the first part of the assignment in a group. Ask for group mates in Slack or here in the classroom, or if you know each other, but you can still do this individually, should you choose. Task 2 and Task 3 are done individually because we're probably at home with our family when we do those, right? Unless you're at home, my place, right? And there are some goals and stuff from the syllabus, and there's some theory I think that you should take a look at. I think that you should take a look at James Bach from software testing and these lectures. Oh, that is a good idea. And then we have the scenario, and you can read that and react on that if you want to. You need to have some kind of background. So let's have an imaginary story, a bit of role play, right? So you're part of this software development company, SDC. Yeah, and they have some goals and stuff. But then you get a software from me, and you get the requirements. Oh, it's my web server. There are some requirements here that you can take a look at, and you also get the source code. Oh, my web server. Oh, well, some weird files, and I'm also so kind that I've created this getting started with the source code. It's abandonware, so I wrote this web server many years ago. Sort of did it in a TDD fashion. So you can run that, yeah. So here's what I want you to do. You should write that test strategy plan, write manual test cases, execute the test plan, and report the results. And this is how to deliver that, how to show that you've done it. So I've created this peer review system that you should input your document into. And in order to have something that is readable for everyone, you should use Markdown. So I've created a link here where you can look at what is Markdown. And you submit this file, and thanks to Oscar and Axel and Rickard, we now know that the system works, right? So we're pretty confident that it works. Please read these important notes. These are important notes, so you should read those. It should be anonymous. You will not be anonymous to me, right? But it should be anonymous to the other groups. No names or traces. Instead, use role names like test lead, scrum master, or product owner, right? Something like that. All students in the group should upload the exact same document so that the system recognizes that you are a group. So you need to share that document. If you're a group of 4 people, everyone should upload the same file. Should you change that file and need to upload a new version, you should all upload the new version. The document or parts of it may not be shared between groups. Right? Do not copy each other in this one. I think that you should read the review task in order to understand on what grounds you will be examined. So below there is the review tasks. Sorry, I'm just going to do this thingy. Yeah, good. So here's the link to the peer review system. But read this and really carefully, because this is the grounds for your examination. So we will use peer review. So after the 23rd of December, the system will put itself in review mode, and you will get access to other people's. By then you have submitted your document. And then you will get access to other students or student groups' assignments, right? And then you're going to read this and review this. And here's the description on how to do that. So since this is the description on how you get your grade, I strongly suggest that you read these before you write your own document, right? So it could be that it should be English. Issues can be related to spelling or grammar. Should use Markdown. Should be in chapters. You should also review the completeness. It should have a test strategy, and the test strategy should answer these questions in a good way, right? It should have a test plan. Oh, yeah. But then there is also a content review. has the other group done a good job reporting the testing of their product? And if you review a group with 4 students, they should have done much more work than a group with 1 student, right? So since there are a couple of weeks until 23rd, my estimated work amount per student is 40 hours. That is put into this. Half time, 2 weeks. 20 hours a week. So this is a big task, right? Normally for assignments, they usually shorter than that. But so a group of 4 students should put 160 man hours into this. Okay, you should also give feedback. You can see that the deadline for reviewing is January 6th. And all reviews should be done by then. And then you have the option to give feedback to students who have, then you get access to their reviews, and you have the option to give feedback to those. Oh, it's not an option. You should do that to all the reviews that you got. You should say, oh, that was a really helpful review. That was really good work. Or, I'm not getting the grade I want. I think you have missed all this. You probably didn't read this. And then there is a process where I will check your reviews and check your feedback and check your test plans, and then I will put a grade on that. But you should know that the grading is sort of set this way. You should have uploaded a document, submitted a review, and responded to reviews. And the reviews that you get, or the grade that you get, are based on these reviews, given that I approve of the reviews. So if someone who has clearly not done the review correctly, I will fail that review. That student don't get a grade for the review, and this student don't get that review as part of their grade, right? Do you understand? So I sort of take a look at all the problems I can find, and then I remove reviews that does not seem to be correct. But you will get a median grade from that score, and you also get the other part of the grade from the score that you get on your reviews. So you need to do both things or all the things in order to get a grade, right? And you can do many reviews. And if you do many reviews, the best one will count. So if you do 100 reviews, you get the highest values for those reviews that I approve of and that students have sort of given you good. But the idea here is not to play the game of getting high reviews. It's to try to understand what makes a good document. How do I judge if this is a good document or not, so that you get to be experts in writing these artifacts and understanding what is a good strategy, what is a good test plan, what is a good test case, what is a good way of reporting this. Do we achieve the goals as said in the scenario? Yeah. Yes, so that is a short walkthrough for that assignment. We have 2 minutes left since I need to run. The assignment 3 is a video presentation. You do this individually. The deadline from that, I think, is 9th of January. So it's the same as the 3rd part of assignment 2. And the idea is that you find one peer-reviewed article. This should be either from a peer-reviewed journal or a conference. And I suggest that you try to find this as soon as possible. And if you have problems, go to the library. The librarians are specialists in guiding you to these resources, so that you find at least a paper or so before you go home for Christmas, right? I've given you 2 links. It's a good idea to go through the university library homepage in order to get the PDFs without paying. But you're allowed to pay. That's okay by me. But I mean, we have these databases for free through the university library, so go through them. Yeah. So you should produce a 5-minute video presentation within the deadline, and it should report and analyze one peer-reviewed paper in a fun way. So find out something good on the absolute edge of science regarding to testing. And it could be that you answer a couple of these questions. What is the problem? What are the scientists trying to solve? Why is that a problem? Why is this important? So what did the scientists do to solve this problem, and what was their result? I think those parts are probably the most important, right? In order to create a good story. It should be in English. It should not be longer than 5 minutes. You're 117 active students on this, times 5 minutes for me to watch. So do not anger me during that process. I also want you to comment on 2 other students' videos. You should present this by posting a YouTube link in Slack. So go into that, and then you post comments on the videos there. Try to find videos that no one has commented on, and take a look at those. Okay, so I have 15 seconds to get to the next level. So this concludes this. Remember that the deadline for assignment 1 is on Friday, right? So please complete that before and ask questions during the tutoring session tomorrow. Thank you very much. Bye.